Welcome to the Junos OS Import and Export Routing Policies module. By the end of this module, you should be able to describe the routing policy and the default Junos OS import and export routing policies. Routing policy permits you to control the routing information flow to and from the routing table, also known as Routing Information Base or RIB. You can apply routing policy as information enters the routing table and as information is copied from the routing table. You can use the routing policy to choose which routes you accept or reject from neighbors running dynamic routing protocols. You can also use the routing policy to choose which routes you send to neighbors running dynamic routing protocols. Routing policy also enables you to modify attributes on routes as they enter or leave the routing table. Routing policy permits you to control the flow of routing information into the forwarding table, also known as Forwarding Information Base or FIB. This use enables you to control which routes you install in the forwarding table and control some of the attributes associated with those routes. Policies that control how the software imports routes into the routing table are named import policies. The software applies import policies before placing routes in the routing table. Thus, an important policy can change the routes that are available in the routing table and can affect the local route selection process. Policies that control how the software sends routes from the routing table are named export policies. The software applies export policies as it exports routes from the routing table to dynamic routing protocols or to the forwarding table. Only active routes are available for export from the routing table. Although an export policy can choose which active routes to export and modify attributes of those routes, it cannot cause the exportation of inactive routes. For example, suppose you have an OSPF route with a preference 10 and a BGP route with a preference 170 for the same prefix. An export policy determines whether to send the active OSPF route and modifies attributes of the route as the software sends it. However, the export policy cannot cause the software to send the inactive BGP route. The Junos OS applies export policies as it exports routes from the routing table, so attribute changes do not affect the local routing table. Rather, the software applies them to the route while exporting it. Every protocol has a default import policy and a default export policy. The displayed chart summarizes the default import and export policies for several common routing protocols. BGP's default import policy is to accept all routes from BGP neighbors and install them in the routing table. BGP's default export policy is to advertise all active BGP routes. For BGP, you can configure import and export policies at the protocol, group, and neighbor levels. The default OSPF import policy is to import all OSPF routes. As a link state protocol, OSPF maintains a consistent link state database, or LSDB, throughout each OSPF area by flooding link state advertisements, or LSAs. You cannot apply policy to affect the maintenance of the local LSDB or the flooding of LSAs. Additionally, you cannot apply a policy that prevents the software from installing internal, including inter-area routes in the routing table. A link state protocol assumes that all devices have the same routing information for internal routes, which causes all devices to make consistent forwarding decisions. If you could block internal routes from entering the routing table, you could create routing loops or cause certain prefixes to become unreachable. However, you can apply a policy that blocks external routes. The default OSPF export policy, which rejects everything, does not cause the system to stop flooding LSAs through the area. Rather, the system always floods LSAs throughout the OSPF area, and the routing policy cannot control that behavior. The default export policy blocks the advertising of additional routes from other sources to OSPF neighbors. If you want to advertise other routes through OSPF, you must configure an explicit export policy. Because link state protocols rely on all participating devices having consistent LSDBs, you can configure import and export policies only at the protocol level. The default policy for RIP is to import all routes learned from explicitly configured neighbors. The software ignores routes learned from neighbors not explicitly defined within the configuration. By default, the software does not export routes to RIP neighbors, including RIP routes. Thus, to advertise any routes to RIP neighbors, you must configure an export policy that matches and accepts RIP routes as shown in the sample output. For RIP, you can apply import policies at the protocol level and neighbor level. In contrast, you can configure export policies only at the group level, as shown in the sample output. Welcome to the Routing Policy, Match Criteria, and Action Blocks module. By the end of this module, you should be able to identify various options in the match criteria and action blocks of a routing policy. Routing policies contain ordered groups of terms. You give routing policies a name that you use to identify them at different locations in the configuration. Terms are the basic building blocks of all Junos OS policies. They are essential if-then statements. If all the match conditions specified in the from statement are true, or if no from statement is specified, all the actions in the then statement are executed. You give terms a name. Note that the name does not affect the evaluation of the term. Rather, it provides a meaningful identifier that you can use when referring to the term. When evaluating the from statement, Junos OS performs the evaluation as a logical or between arguments to a single match criterion, and a logical and between different match criteria. In other words, for the from statement to be considered true, the item being evaluated must match at least one of the arguments to each given match criterion. If a route matches all the conditions in the from statement of a term, Junos OS executes all the actions specified in the then statement of that term, provided one of those actions is a terminating action. The evaluation of the policy stops. The actions that control the acceptance and rejection of routes, accept and reject, are terminating actions. Using these terminating actions results in a first match policy evaluation, because the software takes the specified action immediately and performs no further evaluation of the policy. Note that when Junos OS evaluates a policy, it evaluates each term sequentially. If needed, you can use the insert CLI command in the configuration mode to modify the order in which the terms appear. Here are some of the criteria you can use to select routes with from statements. You can select routes based on their prefix, protocol, some routing protocol attributes, or next hop information. Note that if you omit the from statement in a policy or a policy's term, the software subjects all routes to the referenced action specified in the then statement. You can view the full list of match criteria in the CLI Interactive Help and in the Junos OS routing policies, firewall filters, and Traffic Policer's user guide in the Juniper Networks Tech Library website. You can access this website from the reference links document. You can select routes based on their prefix using a prefix list or a route filter. Prefix lists are named lists of prefixes configured under the Edit Policy Options hierarchy. One of the advantages of prefix lists is that you can use them in multiple places. You can reference prefix lists in multiple terms in a single policy or different policies. Besides, you can use prefix lists both for routing policies and firewall filters, but not stateful firewall rules. This reusability makes prefix lists attractive in some circumstances. You can use prefix lists in two ways in the from statement of routing policies. When referenced in a prefix list statement, routes match only if they exactly match one of the prefixes in the list. When referenced in a prefix list filter statement, you can specify a match type of exact, longer, or longer to be applied to the listed prefixes. You can also specify an optional action to be taken if the filter matches. This action is executed immediately after the match occurs, and the then statement is not evaluated. Route filters are lists of prefixes configured within a single routing policy or policy term. Unlike prefix lists, they are not reusable, but rather are specific to the policy or term in which they are configured. They provide a few more match types for selecting prefixes. As with the prefix list filter statement, you can specify an optional action to be taken if the route filter statement matches. This action is executed immediately after the match occurs, and the then statement is not evaluated. The match type exact means that only routes that match the given prefix exactly match the filter statement. In this example, only the prefix 192.168.0.0/16 and no other prefixes matches the filter statement. The match type or longer means that routes within the specified prefix, with a prefix length greater than or equal to the given prefix length, match the filter statement. So the exact route 192.168.0.0/16 in the example matches the statement. In addition, all routes that are subsets of the 192.168.0.0/16 and that have prefix lengths between /17 and /32 also match. The prefixes that match and those that do not match the statement are listed here. The match type longer means that routes within the specified prefix with a prefix length greater than the given prefix length match the filter statement. The longer and or longer match types differ only in that the specified prefix itself matches the or longer match type, but not the longer match type. In the example, all routes that are subsets of 192.168.0.0/16 and have prefix lengths between /17 and /32 match, whereas 192.168.0.0/16 does not. The up to match type is similar to the or longer match type, except that it provides an upper limit to the acceptable prefix length. The match type up to means that routes within the specified prefix with a prefix length greater than or equal to the given prefix length, but less than or equal to the up to prefix length, match the filter statement. Thus, using the example, the exact route 192.168.0.0/16 matches the statement. All routes that are a subsets of 192.168.0.0/16 and have prefix lengths between /17 and /24 inclusive also match. The prefixes that match and those that do not match the statement are listed here. The prefix length range match type is similar to the up to match type, except that it provides both a lower and an upper limit to the acceptable prefix length. The match type prefix length range means that routes within the specified prefix with a prefix length greater than or equal to the first given prefix length, but less than or equal to the second prefix length, match the filter statement. Thus, using the example, all routes that are subsets of 192.168.0.0/16 and that have prefix lengths between /20 and /24 inclusive match. The prefixes that match and those that do not match the statement are listed here. Given a starting prefix of 192.168/16, what matches with each option? Some intricacies exist in the way that Junos OS devices evaluate route filters when you use differing mask lengths. Junos OS searches for a match between the configured prefix and mask in a route filter, and a given route's prefix and mask. It searches for matches, starting with the most specific route filter entry and ending with the least specific entry. Once the software finds a match, it then evaluates the route against the route filter match type. If a match exists, the route matches the route filter. If the prefix does not match the route filter, the comparison fails, even if the prefix might match a less specific entry in the route filter. Note that it is recommended that you read the How a Route List is Evaluated section in the Junos Policy Framework Configuration Guide before using route lists. Also, you can use the test policy command to test the effectiveness of your policy, including route filters and prefix lists. When using this command, remember that the default policy of the test policy command is to accept all routes. Some common routing policy actions include the terminating actions of accept and reject. These are named terminating actions because they cause the evaluation of the policy and the policy chain to stop, and the route to be accepted or rejected. Note that the non-terminating equivalents of default action accept and default action reject do not cause policy evaluation to stop, but they do override the default policy's accept or reject determination. Other common routing policy actions affect the flow of policy evaluation. The next term and next policy actions cause Junos OS to evaluate the next term or next policy, respectively. Other common actions modify protocol attributes, such as BGP communities, route preferences, and many others. Implementing policy requires two distinct steps. The first step is to define the routing policy. In Junos OS, you define routing policy under the Edit Policy Options hierarchy level. The example code shows a sample policy with 3 distinct terms. Depending on the routing protocol, you can apply import and export policies at multiple levels of the hierarchy. For example, you can apply import policies to BGP sessions at the neighbor, group, or protocol level of the configuration hierarchy. Not all protocols provide policy configuration at all these levels. For example, OSPF enables only protocol-level export and import policies because of the need to maintain a globally consistent link state database, or LSDB. This same requirement also limits the number of changes made by an OSPF import or export policy. Junos OS devices always apply only the most specific import or export policy. Therefore, import or export policies applied at higher levels of the configuration hierarchy apply to lower levels of the configuration if no other policy configuration exists at that level. However, if you configure a policy at a lower level, the system applies only that policy. You can cascade policies to form a chain of policy processing. You can create this chain of policies to solve a complex set of route manipulation tasks in a modular manner. Junos OS evaluates policies from left to right based on the order in which they are applied to a routing protocol. Junos OS checks the match criteria of each policy and performs the associated action when a match occurs. If the first policy does not match, or if the match is associated with a non-terminating action, Junos OS evaluates the route against the next policy in the chain. This pattern repeats itself for all policies in the chain. Junos OS ultimately applies the default policy for a given protocol when no terminating actions occur while evaluating the user-defined policy chain. Policy processing stops once a route meets a terminating action, unless you are grouping policies with Boolean operators. Individual policies can comprise multiple terms. Terms are individual match and action pairs that you can name numerically or symbolically. Junos OS lists terms sequentially from top to bottom and evaluates them in that manner. The software checks each term for its match criteria. When a match occurs, the software performs the associated action. If no match exists in the first term, the software checks the second term. If no match exists in the second term, Junos OS checks the third term. This pattern repeats itself for all terms. If no match exists in the last term, Junos OS checks the next applied policy and then, eventually, the default policy for the protocol. When it finds a match within a term, Junos OS takes the corresponding action. If the action is a terminating action, the processing of the terms and the applied policy stops. Otherwise, the processing continues. Junos OS also supports flow control actions that affect the flow of policy evaluation. The next term and next policy actions cause Junos OS to evaluate the next term or next policy, respectively. Welcome to a Routing Policy Use Case module. By the end of this module, you should be able to implement a routing policy for a given use case. The stated objective for this use case is to use a routing policy to advertise R1's default static route into OSPF. This is a sample routing policy configuration that you can use to advertise R1's default static route into OSPF. This example shows the application of the defined sample routing policy. Note that once the routing policy is applied and the new configuration is activated through a commit, R1 should begin advertising the default route as an external link state advertisement, or LSA, to other routers within OSPF Area 0. This sample verification step confirms that the routing policy works as designed. Using the show route protocol OSPF exact 0/0 CLI command, R4 has added the default external OSPF route to its routing table.